Hey everyone, and welcome to the June meetup for the Melbourne AWS user group. It's meetup number 138. We'd like to start with an acknowledgement of country, and we begin by acknowledging the traditional custodians of the land on which we meet today and pay our respects to the elders past and present. We extend that respect to Aboriginal and Torres Strait Islander peoples, any here today or those watching on our stream. The user group operates on a code of conduct. The full code is in the URL at the bottom of the slide here, and the short version of that is up on the screen. The even shorter version is, just be kind, be good to each other. If anyone has any issues or feels uncomfortable, you can come up and either talk to myself, Dawn at the back, Matt or Rob, the organisers, or there is a feedback on that page if you want to do so anonymously. But thankfully, we've been pretty good through the time, so hopefully no one needs that. You can find the user group info on the web. We have the website at the top. We have LinkedIn. We're on Mastodon, not the ex-Twitter. And as we said, we are streaming on the YouTube as well. There's also a very active Slack, which will come up soon. The format of the night, we start here with the introductions that we're going through. We have a What's New section that Matt will be presenting, and then we'll have Matt Gillard, the first of our instructors, with Move Fast and Deploy Things with SST. And after Matt, Dawn will be talking about sustainable on-call for cloud teams. Once the talks are over, we do a little bit of a marketplace. So for that one, we generally like if people have jobs available to stand up and let people know. You can then go and talk to them afterwards. We usually don't do the, hey, I'm looking for a job, because if your boss is here or watching on the live stream, that might not be the best. So and then usually try and close about 8 o'clock. If you find us on the Slack, which if you have a look at our main website, there's links there. There's a hashtag Melbourne channel, and there's also a chat in the YouTube stream, so you can ask any questions there, and they'll get relayed to the presenters. There we go, Slack's at the bottom there. Or as Bok said, if you do have any questions, just hold them off to the end and we'll bring around a microphone. We would like to thank our sponsors. Without them putting on and running these events would be very difficult. So first off, our gold sponsor, Mantel Group. Our silver sponsor, Civo. And the venue sponsor, NAB, who have put up this great venue for us to host our events. So talking of Slack, this is where the Slack channel is, so melb.awsug.org.au/Slack. Encourage anyone that's not already joined to join up. There's usually quite a bit of chat on there. Have a general channel for general stuff. There's a jobs channel if you're looking or you've got a job. The volunteers, if you want to help out, you can jump in there and let us know. outages channel. If there's something going wrong at AWS, that channel gets pretty active pretty quickly, and announcements give what's new from AWS. So if you want to get involved, we've got a few different options. We're always looking for speakers, and this is a great place. If you haven't done any talks before, really friendly place to get up. We can help you with talks. Have anything from our standard talks, which is sort of around about half an hour, or we're also happy if you want to do lightning talks, sort of shorter, sort of 10 minutes, and they don't have to be super technical. So if you're just starting out, you want a friendly place to sort of talk, you've got something that you're really keen on, yeah, jump in, and if you want some feedback or help, let us know. We're more than happy. Matt, we're still looking for sponsors. So yeah, if your company would like to sponsor, then get in touch with us, especially Matt at the back if you're here in the audience, or hit our Slack if you're watching on the stream. And also to volunteers. So always looking for volunteers, happy to, for anyone that wants to sort of jump in and help out with various things, let us know. So there are also a bunch of other things that are coming up. Who's heard of reInvent? So this is the big AWS conference. It's held in Vegas, start of December. So if you ever get a chance, highly recommend it. It's an amazing conference, but not cheap. So you can have a look, check out the QR code, and look at what's in reInvent. They also do stream a lot of the sessions after. So yeah, go check that out. Sign up even for the free online. And coming up is the serverless meetup. That's on the 4th of July at Mantel Group. So a couple of talks there, setting up CloudFront, and fun with, when I first read it, I read it as Disco bots. Discord bots, probably not as funky, but I'm sure it would be quite interesting. So we have next coming up is what's new, and Matt will come down and give us a wrap up on all that's new and interesting in AWS land.
Definitely not all that's new. Can you use that one? I can definitely do that. Yeah, that's all right. Okay, what have we got? Right. So, what's new for this month? For those of you who have been here a couple of times, you know we have a typical format for our What's New segment where we go through what's new in Melbourne, what's new in Sydney, and then we sort of go through each of the major domains and have a little bit of a chat. I'm going to try something a little bit different this month by having my microphone fall off my shirt, because of course it did. Not quite sure how to put that back on. One moment. We did. It broke.
Did it pop out?
Yeah,
Yeah, it
popped
does
out.
that. I gotta buy a better one.
Anybody
okay.
want to sponsor the group so that we can afford new microphones?
I just paid for a new microphone.
Did I?
No, I did.
Oh, you did. Okay. Yeah, so going to try something a little bit different this month. A little bit more of a rapid fire, get through this so that we can actually get to the two sponsors. Keen to hear... Wow, that's funky. Keen to hear what you think of the new format. Let us know on the Slack channel. Basically, okay, so starting with Melbourne. What's new in Melbourne? Nothing. There were a couple of new instances for EC2, but we don't really care about that. What's new in Sydney? Also nothing. Couple of instances, don't really care about that either, so, congratulations, that's what Australia got this month. Moving on, top 20 announcements, first 5. These are in no particular order, just interesting things that happened over the course of the month. SageMaker Canvas announced up to 10 times faster startup times. For any of you using SageMaker Canvas, this is a big deal. For the other 95% of the audience, you don't care. EventBridge Scheduler adds new API request metric for improved observability. This is really interesting for those of you doing event-based architecture using EventBridge. Makes life a little bit easier. It gives a few more options as to how you're going to trigger things. Again, for the rest of you using containers, Kubernetes, that sort of stuff, you don't care. AppSync now supports long-running events with asynchronous Lambda function invocation. I put that one in there because it's a mouthful and it's fun. AppSync, Lambda function invocation within things like step functions and all of that used to be synchronous, which if you're calling systems that may, integrate with systems like ChatGPT, where it's got a rather long wait period for the response payload to come back, little bit of a problem. This solves that problem. You've got to do a little bit more to handle the asynchronous nature of the return, but it means that your application can do other things in the meantime. Bedrock announces new Converse API. Anybody doing work with Bedrock at the moment? No, little bit. Wow, I have an audience of AWS people who aren't actually doing generative AI. That is actually that's a nice change, right? I'm gonna celebrate that one. If you were, this is cool. You're not, so we'll move on. API gateway invocation timeout limit increased beyond 29 seconds. This got a lot of press on LinkedIn. It is a big deal for some reason. It used to be a hard limit whereby your Lambda couldn't run, you couldn't run for more than 29 seconds. Now you can. There is an argument of thought as to whether or not that's a good thing or a bad thing, and whether or not your API should take more than 29 seconds to respond to a query, but if you have that need, you can now do it. So at least API gateway is now applicable in more use cases. Moving on to the next 5. OpenSearch serverless slashes entry cost in half for all collection types. This is a big deal if you are using things like Bedrock or Amazon Q. OpenSearch serverless used to have a one OPU, CPU, I can't remember what their pricing unit was. They have now cut that in half, so you can now provision half an instance. Don't be a little bit confused, because you still need to deploy it in a multi-AZ configuration, which means you're still paying for multiple nodes, but this does this reduces, when you get to things like Bedrock knowledge bases, if you want to do the whole RAG thing with your LLM, this halves the cost of entry for that sort of stuff. So a little bit of a big deal for those using knowledge bases. Code Catalyst now supports GitHub Cloud source code with blueprints. Anybody playing along with the Code Catalyst realm of things, you've now got GitHub Cloud integration, which is kind of nice. I'll jump around a little bit. Code Build now supports organizations and global GitHub webhooks. That's really nice for integration, because you can run your GitHub Actions runners in Code Build, which means it's an easy way for you to run that within your VPC if you want your GitHub Action script to integrate with your RDS or something behind your firewall. Nice. This now gives you more options to be able to integrate that sort of stuff into the Code Build. It used to be that you only had 1 or 2 webhook options. Now you've got a lot more. Amazon Code Catalyst now supports GitHub Cloud and Bitbucket Cloud with Amazon Q. So for those of you playing along, and this is a little bit of a weird one, but that's okay, you now, when you're doing your coding assistant, because everybody needs their own coding assistant, you now have GitHub Cloud and Bitbucket Cloud integration, which is nice. Moving back up to the middle point here, CloudFormation accelerates dev test cycle with adjustable timeouts for custom resources. Again, it's a little bit of a mouthful. A lot of them were this month. I guess that's what happens when you've been around this long and features start going like 4 levels deep. The takeaway from this one, anybody doing custom resource deployments in CloudFormation will know the pain of making a typo and having a 1 hour timeout for that custom resource when it doesn't provision properly. You got to sit there for an hour, wait for it to fail, then it tries to tear the instance down and it takes forever. So every time you make a failure, you burn about 75 minutes. This now allows you to define your own custom timeout period, so you can be a lot more aggressive. You can set it to like 5 or 10 minutes so that you can get about 6 more swings at the apple per hour. Really nice when you're first sort of crafting those custom resources and constantly getting it wrong. Makes it a lot less painful experience. It means you can actually try more than 6 things in a business day. It's kind of nice. Again, for those of you who are looking at me going, what's a custom resource in CloudFormation? Yeah, don't worry about it. Moving on to the next 5. Again, I put this one in here because, again, it was a big deal on LinkedIn. If this isn't a generative AI group in the room tonight, then it probably doesn't mean a whole heap. Claude 3.5 Sonnet model now available on Bedrock. Yay! The big deal there, it's a powerful model that's cheaper than the others. That's the takeaway. Code Catalyst, because we haven't had enough Code Catalyst announcements. This was a big month for Code Catalyst. Now supports GitLab.com source code. So the takeaway there is you can now do GitHub and GitLab. I don't know why they were 2 separate announcements. I should have combined them. DocumentDB announces IAM database authentication. DocumentDB, MongoDB equivalent, you can now do IAM level configuration. That's a big deal when it comes to things like your Kubernetes clusters. That sort of stuff means that you don't need to be doing the whole secret sharing thing with your root logins and that sort of stuff. You can now do it all through code, which makes life a little bit more complex to set up originally because you've got to deploy your roles and all of those sorts of things, but makes it much simpler to manage on an ongoing basis. Code build supports ARM-based workloads using Graviton 3. This is potentially a big deal for a lot of people. ARM is cheaper, right? So if your code base and whatever your build pipeline looks like can support ARM-based workloads, take a look at potentially moving your code build across onto the Graviton 3. Save yourself some money in your build pipeline. Always nice to be able to do a relatively simple change. I would highly advise testing that separately first because you don't want to break your deployment or your build pipeline because that's bad. But if you test it and it works, it's a nice way to save some money. Introducing Amazon EC2 high memory U7i instances. I put this in here because this is just like shows the level of stuff, the insanity that is AWS. Who wants an instance with 700 plus CPUs or CPU cores? Because there it is. About 16 terabytes. Yeah, I didn't even bother looking at how many $100 an hour these things cost. And I'm going to go out on a limb and say they're not available in Sydney yet. But hey, they are SAP HANA certified. So you know, if you've been sitting there thinking that my SAP HANA workload with its 16 terabytes is too big to fit in AWS, man, I wish I could move this thing off-prem. Well, now you can. I just hope you have a lot of money. But you do because you're running 16 terabytes worth of stuff in a SAP HANA cluster. Marketplace announces amendments for AMI annual agreements. This is one of those things that, again, is going to mean absolutely nothing to most people. But those of you who have subscriptions to IAMs within the Amazon Marketplace, you can now, previously, when you did a subscription, you subscribed a particular AMI to a particular instance type. Right, and that gave you a nice discount. If you needed to, for whatever reason, increase or decrease the size of that instance over the course of the month, you could do that, but you then lost the discount rate that you got for subscribing for a year. This now gives you the flexibility of being able to change your instance type mid-contract. Obviously, there's if you go down, you've got to get more, and if you go up, you get less time. Similar to the way is it the flexible reserved instances work? But yeah, it gives you a lot more flexibility in your Amazon Marketplace contracts, which is nice. Centrally manage member account root email addresses across your organisation. This has been a bugbear for anybody who has large-scale AWS organisations, myself included. This is a big deal, right? This really simplifies the minutiae of running a large-scale AWS organisation. AWS Identity and Access Manager now supports passkey as a second auth factor. For those of you, anybody done anything with passkey? Yeah, if you haven't, and you're running any kind of password manager or anything along those lines, highly advise you look into it. It makes life a lot simpler. This gives you effectively passwordless-like access into your AWS environment. Very cool. I'm going to be playing with this in the not too distant future so that I can report back. And then last but not least, Maven, Python and NuGet support in Amazon Code Catalyst package repositories, because I felt that we needed one more Code Catalyst update for the month. But yeah, so now you can do your Java and your Python and your NuGet and all of that sort of stuff in your Code Catalyst environment. And that is 19 because I thought putting 19 updates then where it says top 20 would just be funny, and I was going to see whether or not anybody picked up on that, but I'm not going to give you the opportunity to do that. And that is it. That's the update.
Good evening. Good evening. Good evening, everyone. I'm giving a talk that I gave at Serverless Days in Sydney about a month ago. About a month. Time flies, doesn't it, Steve? Where are you? Yeah. Time flies. So it's very developer serverless-y focused, so I hope you're ready. It's quite, I got some code samples and stuff, so we'll go through it. If you've got questions at the end, please hit me up. Anyone who does serverless stuff, raise your hand. No one? Oh, it's a little bit? Okay. In general, what are a couple of the things that people find hard with serverless? Just shout out some things. Anyone? Anyone? Testing? Testing, yes, that's a good one. Which one?
Authentication.
Authentication, yes. What about developer feedback for making changes, things like that? There's a lot of different nuances around serverless that are hard and make it difficult sometimes if you're not used to the experience. Like if you're developing on a server, you make a change and it happens straight away, whereas if you're developing in serverless land, things can be a bit complex, maybe a bit slow, sometimes minutes to redeploy things using CloudFormation. So Serverless Stack, SST, short for, provides ways around that and makes the experience better, and that's what I'm hopefully getting across to you today. So who am I? I'm an ambassador along with a couple of other people here, AWS ambassador. Yeah. Some people have been in it longer than me. So Ambassador Program is people in AWS Partner Network who evangelize AWS services and all those sorts of things. I'm a community builder, again. A bunch of us are community builders. Another AWS marketing program, which is good for connecting with the community. People give talks, write blogs, that sort of thing. I'm a co-organiser of the Melbourne Serverless Meetup, which was advertised for next Thursday, July 4. There will not be fireworks. And I'm a principal consultant, capability lead at Civo for Cloud Native. And I'm also a co-presenter of Cloud Dialogues podcast, where we simplify cloud topics for executives in less than 30 minutes, because they have a smaller attention span, any executives who are on the live stream. So to give the example of SST, I had to build an app. So I'm not a front-end developer. I'm kind of not even a developer, but I pretend to be. I do back-end stuff, and I'm learning front-end for a thing that I'm building. This is not what I'm building. This was just a toy app for this talk. So what's a good external API that everyone's using these days? Bedrock, of course. So Bedrock's a good one because it's my app basically takes a photo, put a prompt in, use the photo part of the prompt. And I wanted to use a photo of me and my microphone doing the podcast and make me a bodybuilder or something, so I did that. The picture turned out okay, the face is not really me. And as you can see, graphic design is not my passion. Graphic design / website design is not my passion, but it served the purpose. So this was all deployed using the tools, and I'll run through the architecture. So the architecture is not very complicated. It's very simple and very straightforward. We have a React website, which is hosted on CloudFront with an origin of an S3 bucket. Even to get that running can be complex, right? Using CloudFormation, it's not necessarily simple to put all those pieces together. Sometimes you've got to use blueprints and things to get up and running, and it can be a little bit complex. And of course, if you've got a website, you need some sort of API to expose some functionality to the user. So I've got some business logic there via Lambda functions, one of which we'll call Bedrock to upload the photo and get the result back. Another one to store some data, so I'm storing all the prompts that people do, so you get a history of the last prompts that people have done. People being me, because the website is really only for my use. And an authorization layer, because I don't want everyone to use my AWS account, Bedrock, to do stuff. So the objectives today is to run through the API. So I'll show you how easy it is to define and deploy the API layer, calling Lambda functions at the back end. The back end business logic, how that's wired up, and the database, which is Dynamo in this case. So the other complex thing about serverless is roles, but that's just an AWS thing that, it's always complicated. But SST aims to simplify that as much as possible, but also provide flexibility, which I'll cover. I'll show you how to do the front end and deploy that easily with actually not that much effort. There's authentication built into SST, so I'll show you that. We won't be using Cognito today, but we'll be using an alternative. And the live debugging is like the best part of SST. It's crazy useful to be able to see the changes live and look at variables and stuff. So what is SST? So many have tried different ways of doing serverless. What are some ways people do serverless today? Deploying to AWS. Sam, yes. CloudFormation. Yeah. Raw dog CloudFormation. CDK. Terraform. And there's Terraform serverless.tf, which is the Terraform wrapper around serverless. What else is on the list? I think we covered, serverless framework. I think that's kind of dead. Not dead, but you've got to pay money for it. And I don't think anyone's using it. So it's dead in my books. So what is SST? So it's an opinionated framework for full stack. What that means is that it tells you what you should be doing, but to make it easy. But you can override these things if that's not what you want. It does this by using CDK under the hood, which is not entirely, things are changing there, but I'll get to that at the end. So CDK by itself can be a bit of a beast to get up and running, and not sure what that is. And I haven't done a huge amount of CDK, but I picked up SST fairly easily. Having a wrapper over CDK is actually very useful, which we'll get to. Easy deployment of stages. So normally you deploy different environments of different AWS accounts. That's sort of best practice. Some people might not want to do that. You know, hobbyist projects and stuff, it might be a bit overkill. So if you're deploying multiple things to an account, there's a lot of things you've got to take into account, like name clashes and things like that. If you're deploying multiple environments, and sometimes it can be a bit hard to track if you're doing that yourself. SST has that built into the system. So when you're deploying, you always specify a stage. It could be a local stage on your laptop, it could be a stage, a dev stage, it could be a beta, gamma, whatever, prod. Whatever stage you want, you just call it a name and away it goes. And it filters through all the naming of the resources. And of course local debugging, which we'll get to. So this is just a GIF quickly of the deploying to a local environment, what it looks like. Basically, you just run, it's basically SST dev, and you give it a, in the config, you give it a stage name, and I'll stop the GIF because that's annoying. And that's what it looks like, and then at the end it'll just give you the resources that you've deployed via your outputs that you've defined in your code. So it's easy reference when you're doing your testing. So the structure of an SST application, a lot of the example demo apps basically follow this sort of structure. You have the entry point. So when you run the SST command line, it always goes to sstconfig.ts first, which calls your stacks. And then you define your stacks wherever you want. It could be a stacks directory. And think of that as a CloudFormation stack, effectively, of grouped resources. So I've got a storage stack and an API stack. Package.json for your SST deps dependencies. And then you've got a packages directory where you can have your core sort of libraries and stuff that you need for your app. And then you can have a functions directory with your Lambda functions. You can have any number of directories or structure under there. And of course, there'll be separate package.jsons under there for that. And then you put your front-end code in a directory. Again, sometimes it's in packages, sometimes it's somewhere else. But in this case, I've just used web to host the React app. And it's just a standard React app. I'm using Vite, but whatever React web's front-end builder you use. It all goes in there unchanged. SST will make some minor modifications, but in general, it's pretty stock standard. So our first task is to define our API resources. So we have a construct called API, which under the hood is a version 2 REST API, effectively. And to wire up a Lambda function to a route is literally that simple. So you have, you give a logical ID. So for your API resource, in this case I've called API. Not very creative, am I? But anyway, it's called that. And then the logical ID that gets deployed is the stage name, and then the SST app name, and then that name of the resource. So there's never any clashes between stages. If you don't specify any function parameters, defaults, timeouts, it'll get your default, which is 3 seconds. But if you need to override it, then you can specify your function with a configuration object of your specifying your handler and your timeout, or whatever you want it to be. In this case, I'm calling Titan, so I need a bit of a long timeout. Well, it does its thing and gets response back. So that's the API. So how simple is that? It's pretty cool. By the way, that's deployed functions, the roles, everything. Permissions. Didn't have to do any. It's like SAM's easy to use. This is even easier. So database. I've got a database, DynamoDB, with 2 tables. So I import the table construct from the SST constructs library. I did the same with API, but I didn't show that just to keep the code simple. And then I create my stack, so my table stack, which will contain all my resources, which is function, which behind the scenes provides a stack context with some parameters that I can access if needed. And that gets passed through to all these resources as they get created. So I'm creating a table resource, which is basically a DynamoDB table with my configuration of my partition key in this case, which is just user ID, and another table which contains my request history and an S3 URL. So just for the front end to be able to pull that out later. And then another concept here is that I have my table, but my functions need to be able to talk to my table, right? I defined my functions earlier with default policies, but the policies haven't defined how to talk to the table because I hadn't created the table yet. I've created the table now. So I can bind that table, the table resources I created, so table and request history table. So you can see table and request history table there. They are bound to that API, which means if I put that in the defaults, all my functions and all my routes get access to that table. And binding basically does two things. One, makes the ARN of that table available to all those functions via environment variables. And the other thing that it does is update the policy of the functions to be able to access the table. By default, it'll do a DynamoDB asterisk action, like all actions, but we can refine that, which I'll show you later. So binding is a concept that makes IAM easier to deal with. So we also need an S3 bucket to store images. So again, we create a new stack, which is a storage stack, to hold my bucket resource. Again, I'm just using standard sort of configuration parameters for my bucket. And then I can return the resource from this function to use elsewhere in my stacks if I need to access it, like the ARN or whatever that stack, whatever that construct gives me when it's defined, I have access to those variables. And the other thing is I can add an output, and if I do this output here that you saw when I deployed it, I could see that there. So it provides visibility of that value. Sometimes I might need to refer to it or whatever. So it just makes it available easily seen. And you can also bind, so I showed you binding default to the entire API gateway. You can also bind specific things to specific routes by after the API, well, you can either do it as part of the API config or you can do it afterwards if you've already created the API and your bucket is created later, or then you can still access the API resource. I have an existing route, convert image. I want to bind to that route this particular resource, and that's just to pass an array of things. So in this case, I'm passing my images bucket. Again, that's the binding, which will provide the ARN to the function and update the policy of the function. I don't have to do anything. Another way to so by default, it'll do an S3 asterisk for all S3 actions for that ARN. But I can scope that down by, instead of just providing the object of the images bucket, I can provide an object with some configuration in it and say, actually, for images bucket, I only want to allow get object for this particular list history, right? I don't need to change anything. So then now, instead of an S3 asterisk, I've got an S3 get object, which keeps your security people happy. And we also need a policy to access Bedrock. Bedrock's not defined in my SST config because that's a back-end thing that my functions are calling, but they still need access to be able to run their Bedrock service. And I've just done an asterisk, but you can define that to the model or whatever the standard IAM actions are. And that's using IAM policy statement, which is a standard CDK construct to create a policy statement. So we're mixing SST and standard CDK because you can do that because it's based on CDK. So let's review. We've covered the API. We've covered the configuring the back-end business logic and the database. We've covered easily maintainable least privilege. which is the policies and roles. You know, we haven't had to actually type JSON in policies, which is good because that's can be annoying. Now let's do the front end. How do we configure our front end and what does it do? So again, the front end is, there's a lot of options, but I'm just doing my basic example, which is a static site. Again, it's a static site resource or construct that I'm deploying. And behind the scenes, that takes care of CloudFront, S3, copying images up to it when I'm deploying it, basically everything. So all I do is provide my configuration of where my static site lives, which is that web directory, which I showed you in that first slide of the directory structure. I provide any stack outputs or construct outputs that I have defined that my app needs. It'll need an API URL, right? And that'll change depending on the stage that I've deployed. So I don't have to keep track of stages or anything. All I need to do is know that my API URL is defined there, and then if I'm deploying a dev, a prod, or whatever, it'll get the right value. So I don't have to worry about it. And if you're a front-end dev, you'll know if you're running your front end locally, it'll get passed through as an environment variable, and for testing, your front end. But if you deploy it to production, this will actually update wherever it's defined in the code. When you deploy it, it'll be hard-coded there because it has to be, because obviously there's no environment variables in S3 and CloudFront, so it needs to be defined within the app when you're deploying it out on the internet. So it takes care of all that for you. And this is another example of sort of an escape hatch. So yes, there's an opinionated way on how it defines the S3 buckets, CloudFront and everything, but you can hook into an existing bucket if you want by using the CDK prop or an existing distribution or whatever. CloudFront distribution. So a lot of these CDK SST constructs have a CDK prop which allows you to change that config if required. So we're up to objective 5, which is authentication. So we could use Cognito, and you can do that fine. Alternatively, there's a built-in auth construct for SST, which I'll run you through, which is a way to do authentication at the back end and take care of the whole. It takes care of the OIDC to your preferred provider for your users, and you can take care of saving the username, who's authenticated, what permissions they've got, or whatever. A lot of people like to have control over that and not give that control to your authorization provider. So again, it's an auth construct which takes care of all the authentication. So it's literally a matter of just creating an auth construct, creating a handler to deal with the auth configuration, which we'll get to, binding it to your front end, which is site, so it can access the outputs, and attaching. So once you've got that auth, it exposes, SST exposes that auth construct to your API gateway, so it becomes a route /auth on your API gateway for your application. So it takes over /auth and everything, all the configuration for your authentication starts with the auth prefix. Example for Google. All I want to show you here is that that's not working. Google requires you to have obviously, well, what it'll do is create an authorized endpoint, so it'll actually be called auth Google authorize, which your front end will call, which redirects the user to Google to put your password in. Then the callback will call you've configured your app in Google to call your callback, and then there'll be a /callback on the API gateway, which indicates the user is claims that Google have given you of the user, their picture, whatever, all the claims that the user has. And they're all packaged up into a session token back to the front end, and the front end can save it. And then the way it works is that the front end has this encrypted session token. It passes in a bearer header for every API request. And then the function does make sure it's valid, and then pulls the information out and does what it needs to do. So to be able to configure that in the SST app, you just need you get a Google Client ID, which is your Google app effectively, which you have one for each environment, and a client secret. So in this case, we've got a config parameter, which is an SSM parameter effectively, with your client ID. And you can see that I can access the app stage via the stack context coming through the function. So I know if it's prod, I want to use one, and if it's non-prod, I want to use the other. For a secret, obviously we don't want to store the secret in our code, but we can put a placeholder for the secret, which is called Google Client Secret, and I can update using the SST command line. I can list my secrets, I can set my secrets depending on what stage that I'm using. So you'll notice there's no stage in the name or anything. I'm always referring to it. When I'm deploying, it's always referring to it in behind the scenes as effectively an SSM parameter secret by that name, and it takes care of the stage and all the prefix and everything, so there's no clashes. And so it stores that secret as a secure string in parameter store. And it makes it available. I'll show you how it makes it available in a second. To be able to use those within my code, I just have to use my config. My config is the construct, pulls out destructures the values, and I can use that in my code. As an example, I can bind to my auth handler. My auth handler needs to know how to authenticate, which Google client ID I'm using, which Google client secret I'm using. So I have to bind that to the auth handler, and it'll make it available to that auth handler via environment variables. The client secret will not be necessarily in the environment variable initially, but it'll be fetched. I'll show that in a second. Oh, there it is there. So that's exactly how it makes it available in the console. The Google Client ID is plain text because it's not really secret, but the Google Client secret is got a placeholder fetch from SSM. And when the function does a cold start, it'll pull it out of SSM, and then it'll be cached for the entire life cycle of that function. So it doesn't have to fetch it again. And then in my actual function, there's a hook called config, which basically auto-completes. Once I import that, it knows what the names of my configuration parameters are, and I choose what I need to set my config up. So this is the auth handler function, which I defined previously, and you provide your providers. So you can have any number of providers. You might have a GitHub provider, Google provider, some weird OIDC provider. I've got two, one Google and one link adapter. Link is basically a magic link. So, sometimes you can sign up to something. It'll give you a link to click in your email or via SMS on your phone. So it generates a unique link. The user gets that link and then clicks it, and then they're authenticated. There's a reason I chose that, which I'll get to. The Google one, so I've got an arbitrary name. I could call it whatever I want, but I'll call it Google because that makes sense. It makes it available via that name. So the API gateway, which I mentioned earlier, takes over the auth path. It calls it whatever that provider name is. In this case, it's Google. And then there's the authorize and callback links that behind the scenes that'll get created. For the link adapter, it's called link. So API gateway, auth, link, authorize. So my front end always calls that entry point to be able to start the authentication flow, and then I'll get the callback. And then I have a configuration which will return to the front end. And you can do a /auth to see what you've got configured. So that's just an example of what I've configured in this case. It's the two providers. The reason why I created a link provider is because when I gave this talk at the conference, everyone had a QR code on their thing and people could go to the site with their phone and authenticate using the QR code. So the QR code abuses the link adapter somewhat by, rather than emailing them a link, it returns a 302 to the link. So you go scan the QR code, logs in via the email address on your QR code, and rather than sending an email with a link, it sends a 302 with the actual magic link, so the person logs straight in. And then obviously you can give, in my case I've given some claims, email and given name, which came out of the QR code. We can't unfortunately do that demo today because you don't have QR codes, but that's the background there. And the config here is pretty straightforward for that magic link adapter. So I showed you the high level thing. This is the actual config that you use, the very basic version of it. Rather than that return 302, it should send an email or SMS to the user, but I'm just doing a 302, which will basically redirect the user to the actual link to say they're logged in. Once the user hits the magic link, the on success callback gets hit, which then pulls out their, bundles up their claims into a session token, which gets redirected to the front end, and then the front end can store it however they want to store it, and then provide it in any future API requests, so it's storing it. You grab the token from the URL search parameters. In this case, we're storing it to local storage on the front end in your browser. And then I just have to grab that token with any, in this case, I'm doing a list history API call and providing a bearer token with my session token. And then the back end will use the session hook to pull that out of the bearer token, bearer header, the authentication bearer header, grab the token, check if the user is valid. If it's not, it'll say 401 unauthorized. If it is, it'll continue through the business logic. So that's basically how the auth works. Doing good for time. Last part is the live debugging. So I have a little demo here, which I'm providing a valid token to the API backend, and then I've got you can see the breakpoint where the red circle is, and then the code will stop there like it does, and I can see all my variables in my Lambda function while I've hit my API. So the good thing about this is you can instantly see where something is broken or wrong or not working without having to print. I still do print statements, but but each to their own. Sometimes you've got to see it actually running to be able to visualize what's actually happening. And the good thing about that is I can make a change and rerun it without having to deploy. The way it works is it runs your Lambda functions with a local deployment locally on your laptop via Node. It takes care of, it does it kind of magically. It's documented on the SSD website via IoT core and a local WebSocket client. So it varies the events between Lambda, and it has a Lambda stub function, varies the events, the request and response events back to AWS, but runs all the code locally. So whenever you make a change, it's instantly available. So you can run it straight away again. So it saves a lot of time, especially you don't have to redeploy things. So let's review. So we've done our front end. I didn't have to do much configuration with the front end. I just have to provide the stuff, and then when I do a deployment, it takes care of everything else. Authentication, in my case, it's to limit cost risk of people calling my Bedrock via bots or something. And live debugging, again, I've shown you how to do that. So the key takeaways that I've got for you are SST provides sensible defaults. A lot of the time, all the defaults work just fine, and then you can tune them, especially security as required. And IAM policies are good enough, but you have full control if required. And you can override your CDK. You can use any CDK construct in your app as well. So if there's no SST thing to do what you want to do, you can use the standard one as well. And my personal experience, it removes a lot of the cognitive load switching when you're doing front end, back end. Having it all in one place makes things a lot easier. You can share code a lot easier. There's other ways to do it as well, but I just think SST is probably the best thing that I've used to be able to do this stuff, which I used to be, I love SAM, but now I've switched to this. And fast developer experience feedback. That's a really key thing. So act quickly before they're sold out. That's a little joke that they tweeted. There's a bit of a story behind that, but I thought that was a nice slide to finish on. And there's a QR code which won't make any sense to you, but that's it. Any questions? I know it's a lot of code, it's a lot of stuff, and it's...
Have you got a repo for this?
I don't, but I'm not sure. The code is a little bit dodgy. But there are examples, so what I could do is... so the question was, is there a repo for what I've built? So the answer is no. But I did use a base example image. Maybe are you on the Slack? Yep. I'll post what I've used in the Slack. Maybe privately I can give you what I've done, but the code is really not great.
Okay. Thank you. Very good.
Are there any other questions?
So is it like sounds like it's a framework that you can build like front end, like use front end. Well, it's like it's something. It's a framework that you can actually use to deploy, right?
Yeah, framework for
So
deploying using the tooling. That you
Right.
want,
So
yeah.
if you're already using Terraform, so how do you use?
Then you can't use this. This is
Okay.
Node. Basically, it's node-based for code, CDK-based, and you'd have to. Well, it wouldn't be hard to convert it over. You just have to convert. Terraform would be your infrastructure config. It would be easy to switch over to that.
I'll answer your questions. I might steal this off
yep.
you.
I will also add that.
Thanks.
I will also add that I forgot to mention that the SST is moving to a Terraform Pulumi backend. So the next version, they're moving away from CDK because it's a bit slow. And the new version, which is not production grade yet.
The receiver just died, yeah. Here, this one.
That's better. The CDK and CloudFormation, as we all know, is very quick/slow, slow to deploy. If you do the same deployments with Terraform and Pulumi, it is instant because it's calling the backend APIs really quickly. So SST is moving towards that for their next version. It'll be production ready, I reckon, within months, or maybe even a month or two. And the benefit of that is that you get providers for not just AWS, but they're big on Cloudflare and lots of other sort of things.
One last question over here, and then I'll let
Yep.
Just wanted to double check. I think the last person mentioned it, and then you answered. Just triple checking. So it's only available for Node.js.
Oh,
or
so
TypeScript?
actually, you can do a bunch of different languages. I think you can do Python. Obviously, you can code your lambdas in whatever function you want. I think SST you can do in other languages. I need to check that. But a lot of the functionality, like live debugging, is Node only. So I'm a Python person myself, but I had to relearn JavaScript. Actually, ideally TypeScript is the best thing to use because you get the auto-completion and everything. So I've invested time in that because I think there's value in it. But there are some aspects you can do in other languages, yes.
Cool.
Okay, thank you.
One moment, please, whilst I get set up. as I try to operate this holding 2 microphones at once. So, it's late at night. The kids and or pets and or servers are in bed. You have rolled over. You are asleep. And then you hear,
Trauma.
you roll over again. You grab your phone. You, if you're an iPhone user, slide the little thing to start the phone call. And you hear an impossibly chipper voice saying,
Hello, it's 2 a.m. calling. Your system 253-141-dev is failing to serve more than 20% of inbound traffic. Runbook https:// This has not been updated since before you started .net/deadlink.
We've all been there, haven't we? And that's fine when that happens one night. And then you get to sleep away half the next day, and the system is back up and running. But when that happens every second night, or worse, every night, it starts to grate on you. More to the point, if you were listening very carefully to the impossibly chipper Scottish lady, which, let's be honest, if you were woken up at 2 a.m., you're probably not, you will notice that she referred to a system called 253-141-dev. This presentation is about sustainable on-call for cloud teams. In short, it's about how we don't do that. To begin with, I would like to acknowledge the Wurundjeri people of the Kulin Nation on whose land we meet tonight. This is and always will be Aboriginal land. Their sovereignty was never ceded. Most of you probably know me by now because I'm here every month running the show, most months. But for those of you who don't, my name is Dawn. Technically, my job title is Senior Software Engineer, but really, I'm just a cloudy person at Slack. And I'm qualified to give this talk because I am a lifelong insomniac. I don't need the pager to wake me up at 2 in the morning. I'm quite capable of doing that myself. Outside of work, I am an occasional author and kitchen alchemist. I'm also a raging sports ball fan. There are many people who get into cloud infrastructure because they are sick of being on, or as a contributing factor, because they are sick of being on on-call rotations. There are many, many people who have done this for years or decades and would be very happy to never see another pager again. There are people who go into consulting specifically so that they do not have to deal with being on a pager. I'm going to make the contrary argument here. On-call is a necessary evil. There are very few people who really like the experience of being on a pager, but it has its advantages in certain situations. If you are woken up at 2 in the morning to deal with problems with your system, it is going to make you, provided that you're not woken up every night, more capable of dealing with the types of interesting problems that you would see in an on-call rotation on a day-to-day basis. When you are on that on-call rotation and you get woken up when everything is on fire, you are going to come back the next day or the next week or the next month with concrete ideas to improve the system. So yeah, I'm going to talk about benefits of a pager. And the audiovisual is going to die again. Let me jiggle the handle real quick and see if I can get this to reload itself. We're having a good day, aren't we? I'm also now several slides off where I should be, and it's still not loading. Look, in fairness, I can probably speak without the slides. Benefits of the pager. Yeah, it's controversial, but yes, I will argue that being on a pager has benefits. The first one is everyone has a tangible stake in the state of the system. It does not cost anyone anything to have a system that breaks at 2 in the morning if nobody is responsible for it, if nobody gets woken up. One of the benefits of waking people up is everyone on that on-call rotation has a tangible stake in making the system better. This also gives you a really strong incentive to properly fix any problems that you run into, because you can take a giant piece of sticking plaster and you can stick it over that 253-141-dev system, which is waking you up at 2 in the morning, and then something else will go wrong. The other advantage of having a pager rotation and being on call is the business feels some degree of pain when systems break. Because if you are doing on call, not necessarily in all jurisdictions, but as standard practice, the business should actually pay people for being on that on-call rotation and should pay people when they wake them up at 2 in the morning. So there's not just a cost to the people on the rotation, which incentivizes them improving their systems. There's also a cost to the business. And you might say, but I like sleep, as I attempt to jiggle the handle again. Yes, I have some degree of sympathy for the position of, but I like sleep. But at the same time, I can't relate because I'm a lifelong insomniac. Just imagine here a picture of many cute kittens that have fallen asleep on a bed. Regrettably, because the AV has died. There we go. I like sleep as much as these cats. I definitely don't guess as much as these cats do. And yes, we all like sleep. And yes, being on an on-call rotation is massively disruptive to people's day-to-day, which is why one of the really important things about on-call is that it's appropriately remunerated. And I will not lie, there are downsides to this, which is why it's really important to do it properly. Because when it goes sour, it goes really, really sour, and I have been on on-call rotations like this. I have been on on-call rotations where you would get into incident reviews, and there was absolutely no interest in uncovering what the ultimate problem with the system was. You just had a bunch of people who were looking for someone to blame. Finger points here, finger points there. Don't do that. That's how not to do an on-call rotation. Other really common problems. No clear chain of accountability. And I'm not saying here that we should be casting blame on particular people. What I'm saying is that there should be a person or a group of people who are responsible for maintaining system health, where you can actually go to that person and say, okay, system X broke and we had to page someone for it. You are responsible for making sure that these tickets get assigned to someone so that they get remediated. Which is a real problem if you don't have enough time or resources to actually fix these issues. Another really common one, not enough people on the pager. I have seen many people, the absolute opposite of the people who go into cloud because they do not want to ever deal with a pager again. I have known people who thrive on being on call. But you can only do 100% on call for so long before it starts to wear on you. You can only do 100% on call for so long before it burns people out. And you also need some sort of process for identifying when people need to stop. And sometimes that is, okay, you have been woken up every night for the past 3 weeks. We need to get you off the pager so you can get some decent sleep. And sometimes that's, we have had this incident going for 24 hours and you're still here. You were here at the beginning. You're still here. You've not gone to sleep. It is time to turn off your machine. But I wouldn't be here talking to all of you if this wasn't relevant specifically to working in the cloud. Because on-call for cloud teams is slightly different to on-call for developer teams in some very critical ways. And this is the second time in less than a week that I have got to talk about a certain pair of US East 1 outages which happened in December 2021. Anyone remember those? That was a good month for people who were on call to make some pretty serious money doing overtime. Because one of the things that your cloud teams can do that most other people can't is liaise with the cloud providers. The cloud teams are the people who know your technical account managers. They know who your contacts are. And that means that we very often, if you're on a cloud team, the collective we, will be the people that get called in to have those conversations because you have prior relationships, because you're often the people that will have to do the first level of debugging, and then it just makes sense. Cloud systems are used by a bunch of other teams, particularly if you're running a cloud platform team. On call for that cloud platform team can look like fixing your own problems. If you run a cloud platform team that maintains all of, let's say, the CloudFormation resources that other teams build on, and you go and make a change to one of those CloudFormation resources, and someone hits a button on a pipeline, and suddenly that's broken all of your security groups, and now you've got stuff that's wide open to the internet. Your cloud team is the group of people that are going to be called in to fix that. Cloud teams are also and this is where it gets dicey, cloud teams are also the ideal group of people to troubleshoot cloud infrastructure issues. We have the technical understanding to be able to go in and do deep dives into those systems where the teams that build on top of our platforms might not. Hold that thought, because we're going to come back to it. So what else is different for us in terms of specifics? I mean, like I just said, we are the subject matter experts by default. If you need someone who knows AWS, you're going to be going to the cloud team. If you happen to use Azure or GCP, you are going to be going to your respective cloud team to get that subject matter expertise. This is great. The caveat with that is not every team owns the cloud platforms, but in the vast majority of businesses, just about every team builds on the cloud platforms. And that means that if you don't have a sufficient baseline level of knowledge, we, as as members of cloud teams, might not actually own the systems that we're debugging. Similarly, our customers are usually going to be internal teams, not external teams. Even if a cloud team makes a change themselves that breaks some aspect of the system, the first people to realize it are going to be the teams that build on that cloud platform, and then the external customers. You've essentially got a layer between you over here and the customer all the way over there. And we are much more likely to work with issues at the cloud provider level, which means that in some cases we are going to be working with issues that are caused by AWS or Azure or GCP. So let's talk, we've talked about how this is different for cloud teams. Let's talk about how not to stuff this up. Because if we go away and we build our systems and something goes wrong and we get that alert with the impossibly friendly Scottish voice going, "Hello, it's 2 a.m. calling," there are some really critical questions to ask yourselves here. The first one, are we measuring the right thing? Because it is really easy to spin up an EC2 instance and go into CloudWatch and get a whole bunch of metrics. You can get metrics for just about everything you want. You can get metrics for CPU usage, you can get metrics for network usage, you can get metrics for all kinds of different types of bandwidth. But are any of those metrics by themselves going to tell you that the customers building on your system have a problem with it? Because you can quite happily run EC2 instances at 95% of their capacity, as long as they're still serving all of your customers appropriately. Similarly, do we have enough telemetry to actually understand what is going on? CloudWatch alerts, CloudWatch alarms are binary. It's either in an alarm state or it's not. So do you then, from that, have enough telemetry to actually understand what is going on at each different layer of the system? Do you have more than just that one alert that's pinging you? Can you go deeper in? Can you look at many different metrics? Can you look at a full history of the metrics? Does this problem need to be fixed now? And if that problem is on a system called 253-141-dev, the answer is no. That problem does not need to be fixed now because we do not need to be waking people up in the middle of the night for dev systems. That is a really, really bad idea, and that is how you burn people out exceptionally quickly. So, if you are running sandbox systems, if you are running dev systems, if you are running staging systems, you do not wake people up at 2 in the morning for alerts on those systems. If you are running a production system and your EC2 instances get to 95% capacity, but your customers are seeing absolutely no impact whatsoever, does that need to be fixed now? Do we need to wake someone up at 2 in the morning to fix this problem, or can we let the scaling rules kick in? Is there a clear runbook for solving the problem? And I put a caveat on this, because runbooks can be really problematic in the sense that we can get into the habit of going away and writing up the runbook at "this has not been updated since before you started .NET/deadlink," putting a bunch of information in there, and then every time an alert recurs, we rely on that runbook to fix it when we could be automating the fix instead. And sometimes that is a case of you take the steps in the runbook, you write a script, every time that alert triggers, you run the script. If the alert triggers again, that is when you wake people up. Sometimes it is a case of we look at the system and we go, why are we waking people up at 2 in the morning once a month for this particular problem? Can we architect around it? So yes, runbooks are really important, but here be dragons. Anyone who has worked on an SRE team or a development team or probably internal platform team, the likelihood is that you've heard of the Google SRE handbook. And this is the benchmark by which a lot of teams operate a site reliability engineering team or site reliability, the site reliability engineering culture. A decent chunk of the Google SRE handbook discusses how to operate a pager that doesn't horribly burn people out. And Google have decades of experience in doing this, and by all accounts from people who work at Google, they do this really well. The SRE handbook, I would recommend if any of you are interested in how to operate a reasonable on-call rotation, go and read it, but think about it critically, because it was written a number of years ago. The industry has evolved. It may not work for your particular use case, but there are still some really important ground rules for how do we operate this, how do we operate on-call at a basic standard? And some of these are pulled from the Google SRE handbook. Some of these should just be common sense. Like again, don't wake people up in the middle of the night for dev systems. Don't wake people up in the middle of the night for issues that are not time sensitive. If you can fix it, if your time to fix an issue is 24 hours before it completely explodes the system, don't wake people up in the middle of the night for that. Stick a notification somewhere, leave it so that when people wake up the next morning, they can then deal with it then when they've had a full night of sleep and they're fresh. One thing that's really important to consider, and we'll get to that more in a minute, is if you wake someone up in the middle of the night, you get diminishing returns on their ability to solve problems. If you repeatedly wake people up in the middle of the night so they're not getting proper sleep, those diminishing returns compound. So only waking people up for time-sensitive issues is really important. Equally, adequate recovery time after pages, and that includes false alarms. If you wake someone up at 2 in the morning with the impossibly chipper Scottish voice, and then you expect them to be in the office at 8:30 the same morning, you are going to get someone who is tired and yawning, and they are not going to be able to do their best work. In some cases, even if that's a false alarm, you're going to get someone who's not slept between when they were woken up at 2 in the morning and when they arrive in the office. And so sometimes that means you just need to have it built into your culture. If you get woken up, we don't expect you in bright-eyed and bushy-tailed at the start of the day. Go and get some sleep. One line from the Google SRE handbook that's really important is people should be on call no more than 25% of the time. You need a team of 4 people who are on call to be able to appropriately staff an on-call roster. Once you get beyond 25% of the time, and I can say this having been on a pager 50% of the time a couple of times in my life in previous jobs, I can attest that the diminishing returns are real. And obviously, you need to appropriately remunerate it. depending on the jurisdiction that you're in some cases, it's illegal to not have on-call allowances and to not pay people overtime. In other jurisdictions, and depending on your local labor laws and the contract, some companies will just roll it into their base pay rate and there'll be an expectation that you're then on call. But it is also really important to have a cultural standard. Coming back to that, I've been in some incident reviews where people are not actually interested in solving the problem. Many, many years ago, I've been in some incident reviews where people are not interested in solving the problem. They're just shouting over each other trying to figure out who was responsible for this. Blameless IRs. Because if you get, let's say everyone here in this room was in an incident review, and we're all just shouting over each other, trying to find someone to blame. Two things happen. The first one is nothing's getting fixed. The second one is people, next time it happens, next time you have one of these incident reviews, people are going to be less open, they're going to be less honest, and they are going to be less frank about what the issues are. Solving systematic issues requires spicy takes sometimes, and it requires listening to those spicy takes sometimes. Bad IRs are arguably worse than not doing them at all, because if you're going to get a bunch of people in a room and they're just shouting, trying to figure out who to blame, that distrust, that cultural distrust will then compound. You are actually better off not trying to investigate it at all, because that's when you get into a culture of people hiding things. You should know when, how, and who to escalate an alert to an incident. And you should know how to appropriately respond to it. Who do you need to page in? Who do you need to get involved? One of the tricks with cloud teams is if you are responsible for the AWS infrastructure, there are some situations where you're basically going to be the team that gets paged in. So some other team with some other system, say if we're talking those US East 1 outages, there are bits of Route 53 that are single points of failure. So the team that's responsible for your Route 53 pages in the cloud team and goes, hey, what's going on here? But even if you are the cloud team, sometimes it's going to be, customer A of the cloud team has caused an issue on our system, which is then affecting customers B, C, D, and E. And so we then need to know, okay, who are the appropriate people to page in for these sorts of problems? Do we need to page in B, C, D, and E to let them know? Do we need to page in A to be able to fix it? You need to check in on a regular basis to stop people from burning out. Again, can attest, have been on some pages where I was on 50% of the time in the past and have spectacularly burned out on one of those to the point where I basically asked to be taken off the pager. Because, again, once you hit that point of diminishing returns, it snowballs. So it's really critical, have the discussion with the other people on the pager. Are we all feeling okay? Do we feel like we can manage this workload? Do we feel like there are more people that we need to pull in to help? And make sure that you have some kind of metric to figure out whether you are improving. We will get to some specific metrics later, but a couple of easy ones off the top of your head. Are we waking people up for dev, sandbox, staging, UAT systems in the middle of the night? How many pages do we have this month compared to last month? That's a really simple and easy metric that can tell you, okay, are we improving or not? So on a cloud team, how do we actually implement all of this? Ooh, as this jumps one slide ahead. So from the Google SRE handbook, this is pulled verbatim from there. You're 25%. You need at least 4 people to be able to maintain an on-call rotation. If you have less than that, people will burn out, I promise you. I've worked on some geo-split teams. I've worked on a geo-split team in the past where we did on-call with a team in Australia and a team in India. If you want to do that, assuming that you have an even split between the 2 jurisdictions, you need at least 6. So 3 in each jurisdiction. This has the advantage, depending on which jurisdictions that you're talking about, that there is a smaller window of time outside of work in which you're waking people up. In some cases, if you've got jurisdiction spaced appropriately. You can do follow the sun, where people just do on-call during work hours, but even then, you need to have enough people to appropriately staff that rotation. If you have enough people, consider implementing a secondary rotation. This is really good for getting people up to speed with on-call when they're not super confident with the systems that they're working on. But again, to stay under that 25%, you need more than 4 people to have a sustainable secondary rotation. Another critical point, much to, to probably groans from anyone who has spent decades on pages, everyone on a team should be on call. There are obviously going to be some situations, there are going to be medical exemptions to this, there are going to be some situations where it's not realistic, but by and large, the pain should be shared. If people aren't on the on-call rotation, those people don't have a direct stake in what's going on in the system outside of hours, and that's really important. So how do we then do the actual alerts? There are a few different things here. The first one is, particularly if you work at a large enterprise, you do not want to take everyone's alerts and put them in the same bucket. If you have a cloud team that's responsible for 5 different systems, you don't even want to take all of the systems and put them in one bucket, because there are a few things. The first one is reshuffles happen all the time. People leave, people's responsibilities change. Services get moved between teams. And that's particularly common in the cloud world, where you might have, a team that handles serverless and a team that handles Kubernetes, and then you have to shuffle around some responsibilities and everything gets rather complicated. So you want to be able to have easy units that you can just go, okay, we go into whatever our pager platform is and we just reassign this from one team to another. It's also easier then to collect metrics by service. It's a very different situation if you have people being woken up at 2 in the morning every day for 5 different systems with the alerts spread equally, compared to you've got one system that's persistently waking people up at 2 in the morning. It is also a really good idea to basically parse out, this is important, this is high severity, this is what we wake people up for. This is not important, this is low severity. We need to surface it because it might give us information about general system health, or if it happens during work hours, it might help us prevent an incident. But it is not something that we need to wake people up for. PagerDuty provides this out of the box. I know that there are some other providers that do the same thing. If you want to get really sophisticated, you can basically set this up so it's like, okay, you can set it up in 2 different ways in terms of increasing in severity depending on the threshold. One is you can basically go, okay, we've got metric A here, metric B here, metric C here. Say 50%, 75%, 90%. At 50%, we notify people. At 75%, we notify people again. 90%, something's gone wrong, we wake people up. The other way that you can do it is if you have had certain problems which have stuck around for a certain duration of time, you might start by notifying someone and then say, okay, well, if this hasn't changed in an hour, that's when we want to wake people up, because that's the sign of, we're not just missing a couple of data points here, or it's not just someone who's run some junk data through the system. We are actually getting persistent failures. And you generally want to find some way, basically, for your low severity alerts to not wake people up. But if your pager system is just an on-off, you can bypass it completely. I mean, plug for Slack. I work there. It is a great piece of software. You can just grab your data, stick it into a Lambda function, send that to a Slack channel. That's a efficient way to notify people, and that has the advantage that it's searchable. If a provider gives you the severity out of the box, that's great. If you're working with something that's not sophisticated, there are still options for this. Let people know what you have investigated and changed. The communication and handover bit is really critical here, because when you're running into long-running incidents, you want to make sure that everyone is up to date as they're cycling out, cycling in. The other scenario where this is really important, the communication and handover bit, is as people go on call and off call. If you've had, one recurring alert that you're working on resolving, it's critical to give that information to the next person so that they know, they're prepared, they know what the steps are, and they can keep just chipping away at the problem. Again, plug for Slack. Slack threads work really well for that, but anything searchable will do. Stick it in a Git repo, put it in Confluence, put it in Notion, wherever. If you need to make improvements, make sure that they actually get tracked somewhere. Make sure that they go into your ticketing system and they don't just stay in people's heads. Because again, if you've got a problem which happens and then it stops and then it recurs, you want to make sure that you're actually tracking that piece of work, and then you can go, oh, we've got that change, we need to bump that up in severity a bit. And if you have common issues that you might need to deal with, update your run books. But again, beware that you're not relying on the run books to sticking plaster over bigger problems with your system that you need to actually address. And if we want to do data-driven on-call in the same way that we would want to do data-driven everything, let's, to close out, talk more specifically about the metrics. As once again, I go one slide too far. So there are a few here. Really obvious one. In a period of time, how many incidents did we have? Did we wake people up once a day? Did we wake people up once a week? Have we gone 90 days and not woken anyone up at all? That's the ideal. Strive for that. That's great. Because at that point, you're just getting paid to be on a pager and have a phone with you without actually needing to lose sleep at 2 in the morning. But another really important thing to parse out is how serious were the alerts that we got? How serious were the incidents that we had? Are we talking like we're waking people up once a day, but it's for minor issues? Or are we talking the whole system's going down once a day? Because if the whole system is going down once a day, the business that you're working for is probably not going to be a going concern in 6 months, and you might want to dust off your resume and start looking for a new job. Another really important metric, time from detection to resolution. And you can measure that in a lot of pager systems and alerting systems. You can also measure that in your incident response. How long did it take us to realize that we had the problem? How long did it take us to resolve it? There are a couple of other metrics which having a good alerting system enables you to look at. The first one is the percentage of incidents that are detected by alerts. So something's gone wrong. We need to pull in all of our responders. Our customers are grumpy. This actually merits an incident response. But how did we detect it? Was that from our customers calling us up and saying, hello, it's 2 a.m. calling. I'm trying to use your system and I can't use it. Dear 24-hour helpline, please go and page the people who are on call for this. And for some products, that is not realistic, but try working for a bank. So or was that woken up through a wholly automated system where it's like, okay, we've detected that something's wrong, we paged someone in, we knew that it was going on before there was customer impact. So that's a really important one to look at, like, how many incidents are we actually detecting with our alerting system? How many incidents are coming to the on-call people before we've got angry customers complaining? The other really important one is the percentage of alerts that lead to incidents. And that's essentially your false positive rate. So if 75% of the time when you're waking people up, it's not leading to an incident, there's the question then of, okay, how do we sit down, how do we actually parse that out and look at the noise in the system? Why do we have so many things that we're alerting on that aren't actually indicating problems in the system? Whereas if 90% of your alerts lead to incidents, that's great, as long as you are also detecting a reasonable percentage of your incidents with alerts. So those two numbers are kind of crude metrics that can give you some idea of how effective your on-call response is, but how effective everything underpinning that is. The metrics, the observability. It is different for cloud teams. It sucks to be on a pager, but when you get that phone call that's basically going, hello, it's 2 a.m. calling in the impossibly chipper voice, Hopefully this at least gives you a roadmap to figure out how to make sure that it's not for system 253-141-dev this time, and you're not being woken up needlessly. I think we've got, between Matt and I think we've gone slightly over time, so questions will probably have to be on Slack, but the email address works. That's a GitHub repo with an almost complete history, because it's now a couple of months behind, of every talk I've ever given. I'm always around. Come find me. I'm one of those weird people that actually likes being on a pager and likes improving this sort of stuff. So if you have ideas, again, come find me. Thank you.
If there were any questions, I think we can squeeze one in. Nope, good. Otherwise, just grab Dawn afterwards. Yes.
Extremely flying.
All right, so we're just about to wrap this up, and pretty much close to the final segment is the marketplace. Is there anyone around that's hiring at the moment? Yep. Okay, so that's all good. We'll move on with a final thank you to our sponsors, gold sponsor Mantle Group, silver sponsor Sivo, and a special thank you to NAB for putting out this venue for us to host. We really wouldn't be able to have these without all those sponsors. And yep, especially have our guests as well. Without our guests giving the speeches, the talks, it'll be fairly boring. You just have to put up with Matt. So again, thank you. And if anyone has any talks that they would like to give, you can jump up onto the website, and there's a place to submit your talks. And we would love to get them. If you're not sure on what to do, we can certainly help you there.
And sorry for having put the mask on already. Plug for, we are still looking for some more sponsors. So if you happen to work somewhere that might be interested in that, or know someone who works somewhere who might be interested in that, come find us on Slack. We'll make sure it gets to the right people.
Thank you, Dawn. Yes. And so finally, our next meeting is Wednesday, the 31st of July. So we'd love to see you all back here again next month. You can sign up on meetup.com to get notifications on our meetings, but it's basically the last Wednesday of every month. So with that, let's say thank you all for coming, and hopefully we'll see you next month.